Alright, let's look at the translation on the s-axis. Alright, so if you take the Laplace transform of e to the at f of t, then you will get the f of s minus a. So you can see that this e to the at is going to be the translation. So it just shift to the right by a, right? And of course you can reverse it. So if you take the inverse Laplace transform of capital F of s minus a, it's going to be e to the at f of t. Alright, so proof of this is actually fairly simple. Alright, so I'm going to start with the right hand side, which is capital F of s minus a. Alright, so by definition, this is going to be integral from 0 to infinity. You're going to have e to the negative. Instead of just s, we're going to put the s minus a t. Then you have f of t dt. Right? Then I'm going to separate this. Alright, so you have an integral from 0 to infinity. Then you have e to the negative st. Right? Then you have e to the positive at. So you have e to the positive at f of t dt. Right? So you can see that this is the definition of the Laplace transform of e to the at f of t. Right? So that will verify this equation right there. Alright, so let's look at a couple of examples. Alright, let's find the inverse Laplace transform of 1 over s squared plus 4s plus 4. Alright, so first I'm gonna complete the square of the denominator. So we have 1 over, and you can see that we can complete the square as s plus 2 squared. Alright, then you can see that if you take the inverse Laplace transform of, alright, so I'm gonna ignore the translation, so plus 2 here, so 1 over s squared. Alright, so this is going to be just t, right? So all we have to do is, it's going to be f of t is just t in this case, right? So I'm going to put t there, right? But the translation is e to the negative 2t. Alright, so this is the inverse Laplace transform that we're looking for. Alright? Alright, how about the second one? Inverse Laplace transform of 3s plus 5 over s squared minus 6s plus 25. Alright, I'm going to complete the square again. So you have inverse Laplace transform of, if you complete the square, we're going to have, let's see, we have s squared minus 6s. So if we have 9 here, I can write s minus 3 quantity squared, right? So we have only used 9 because a negative 3 squared would be positive 9. So, but we have 25, so we have 16 left over. So I'm going to write 16 as 4 squared. Alright, then the numerator is, I'm going to just write it down. Actually, I'm going to write it this way. So since I want to have s minus 3, so I'm going to put 3 times s minus 3. So that will be 3s minus 9, alright? So we have plus 5, so we're going to have to, so instead of minus 9, we have to have plus 5. So I'm going to add, let's see, 14 to it. Alright, so this would be the same thing. Alright, then we can just split this in two. Alright, so we want to find the inverse Laplace transform of, so I'm going to write it this way. So I'm going to put the 3 in front. Alright, then I'm going to have s minus 3, right, over s minus 3 squared plus 4 squared. Alright, and plus, I'm going to pull 14 outside. Then I would like to have 4 here, so I'm going to put 4, then divide by 4. Alright, then we have s minus 3 squared plus 4 squared. Alright, so this is going to be, alright, so let's take care of the shifting first. So minus 3, so it's going to correspond to e to the 3t. Right? Then you have, so here, we took care of this shifting here. Right, translation. Alright, so we take care of 3, so I'm going to put the 3 in front. Right, actually, so that's the translation too. So if you look at the s over s squared plus 4 squared would be, that's cosine of 4t. So we're going to have cosine of 4t. Alright, plus, alright, so actually 14 over 4 is 7 over 2. So I'm going to put the 7 over 2. And then is 4 over s squared plus 4 squared is a sine of 4t. Alright, so that's the inverse Laplace transform with the translation on the x-axis. Alright, that's it. I hope that this was clear.